Hello and welcome back to the shop. I know on one of the last videos I promised to do a kind of tool holder shootout between the AR101s and some cheaper versions of that. Unfortunately, I just haven't gotten enough progress done on the Bridgeport to even be able to get to my lathe, to be honest with you. I have everything piled up in front of it. So hopefully by the end of this week here, I had to order a couple of bearings for the table feeds because they were a little bit crunchy. But once I get the knee on the mill and get the start getting some parts of it together, I should be able to clear out this area really easily, and we should be able to get to it by next weekend. So this is going to be another Bridgeport video, and we're going to be working on the mainly the power feed, and we're going to clean up the table a little bit. As far as the tool holders go, like I said, I do have those planned, and what we have here is a Shaw's version of a SC-LCR holder. We also have a stand-up threading tool from Shaw's. We have a really offshore direct SC-LCR holder, and we also have a boring bar. And they all look, at first glance, pretty good quality, halfway decent. Now I also have some Shaw's inserts I want to try out. This gave you a regular CCMT 3251 on there already, and I picked up one that was had a black coating to it, and I also grabbed a CCGX, which is the aluminum bit, and I wanted to kind of put the, it's about $6 a pop, version of those against a more expensive brand. So that's definitely in the works, and we'll have a good review about that. So anyway, let's get to the cleaning up the Bridgeport here. We'll take a look at the table, we'll get that nice and clean, and then we'll work on the power feed, just as a change of pace. Alright, I mentioned earlier about this mill that it came from Harvard's cyclotron lab. Now, this is a 1978 by the serial number, and actually also on the circuit board of the power feed stamps 1978. Now, the cyclotron lab has been in existence, or the cyclotron itself has been in existence since the 30s, and it's gone through a few incarnations. And then they built and housed a whole new building for it, and then transferred it to Mass General Hospital. And also, I believe it was shut down in 2002. Now, they used the cyclotron not only in physics research and to create short-lived radioactive isotopes, but it also was used for radiation therapy in treating cancer. And they would focus the beam of radiation to a specific point on the patient's body. Now, if you look up the Harvard Cyclotron Lab and the machine shop in particular, there's a name that always pops up, and so I managed to actually track this person down, and he worked at the cyclotron lab machine shop, ran the machine shop from 1981 until it closed in 2002, and he has since retired. And I was actually able to get in touch with him, and I asked him if he would be willing to have a conversation with me, and he said yeah. So he gave me his phone number, and I talked to him, and I just wanted to find a little bit more about what they actually did there with these machines. So I was talking to him. What they had in the shop, they had 3 mills, 3 J-head Bridgeports. They had this green one here. They had a gray one that had ball screws, and they had one that was converted to CNC, but unfortunately that didn't have ball screws, so they had to take into account backlash into every program that they wrote for it. They also had 2 380 CNC machines, and they also had a South Bend 10-inch lathe there, and that was in cut-off saws and things like that, and that's what they worked on, worked with. Now, what they actually did there, not only as maintenance for the cyclotron machine itself, their primary job was to make apertures to focus the radiation. So an oncologist and doctor would tell them, I need an aperture to focus the beam of radiation to this point on a person's body or whatever. And what they would do is they would make, using these machines, an aperture that consisted of a giant 1-inch brass block and a piece of basically plexiglass. The plexiglass they had was just a round tube, and they sliced it off like bologna. And they sandwich it together with the brass piece, and that would be able to focus the radiation into the patient's body. So they had different apertures. They also had one, he said the most complicated one that he made was for colon cancer. And it was a tube with 2 complementary angles. He said it looked like if you made your hand into a hook. So you had to make an angle, make another angle, put it all together. And that was actually for colon cancer. So they shoved it up somebody's rear end to focus the beam of radiation into a specific spot on their colon. And now they're going through a ton of brass and a ton of everything. What they would do afterwards, they would take all this brass out of the cyclotron and it would be radioactive. They would store it in a special room for X amount of days. And then what they would do is they would take it out, and after that certain amount of days, double check it, test it, and then it would go off to the scrapper after it cooled down. The radiation dissipated from that part. Now the man that I talked to, he was in the trade for a long time. He was in the military. He was in the military. He quit school, joined the military, Navy specifically, and ended up as a gunner's mate, even though he wanted to be a machinist mate. But he ended up working for GE for, I think he said 25 years before technically retiring from there, and that's when he got the job at Harvard. And he said it was really fun. It was interesting. He liked doing the work, and he was telling me about a bunch of different projects that he did in the shop, and a bunch of things that had happened in there. It was really interesting hearing a lot of the stories, and like even him making out of the scraps of the plexiglass they have left over, making a program for the CNC machines to make cribbage boards. And he even said he still has one of the cribbage boards at his house. And I was talking to him. He's like, "Yeah, I'm sitting here in my office right now in my house, and I'm looking up at the wall, and in a shadow box on the wall, I have framed my 1, 2, and 3-inch mics. And all my friends come over and say, 'Why don't you sell those?' He's like, 'Well, I can't because they were my father's, so they're gonna sit on that wall until I'm gone.' So it's just very interesting talking to him, and yeah, I mean, you could tell he liked what he did. You could tell that he liked what he was doing over at Harvard. It was just a really, I sat on the phone with him and talked with him for a good hour or so. It was just a really cool conversation. So anyway, so we're gonna get to actually working on the power feed here in a minute, and taking that down and replacing the components that need it. So let's get to that. Okay, so now we're just going to take a little detour because I can, and we're going to clean up the power feed here. The reason why I want to do this is just because, well, I can. So, I want to take a little break from scrubbing, and we'll do some cleaning on this, but a lot of it is electronic. So anyway, so here is neutral, so you can see we rotate freely, and we'll put in a feed direction, and you can see it locks. I'm going to turn it on, and we're going to turn this little potentiometer, and you can see we start right up. And then we have rapid traverse, and then opposite direction feed here with rapid traverse. So now, main issue we have with this is this plug has pretty much had it. There's no strain relief connector on the end here. This light is dead, and this fuse holder's toast. I actually just had to jump it out just to see if everything worked. So what I'm going to do for now is I want to clean everything up. So I want to take the handle off, I want to take the bushing off, I want to take all this off. We'll see if we can get the gearbox in here cleaned up, and we'll basically try to strip this down to as bare bones as we can without messing with a whole lot of the electronics. I'll pull up the board here and see if it's really easy to disconnect it from this this casing here, but I don't want to mess with a lot of this electronics at the moment if I don't have to. And I can see that the micro switches here are actually screwed into this housing and not this housing, so the whole electrical section technically is not going to come off all in one shot. So there's two cap head screws that hold this whole housing, electrical housing here, and then there are two Phillips heads that hold a board that holds the trip mechanism here and the two micro switches. So we'll see if we can take this whole thing off in one spot, separate the mechanical from the electronic. So give me a minute. So we're looking at 1978 technology here, and here's the board. It's all through mount components. It's all basically resistors, caps, and pots, more or less. There's 4 pots here, which I'm assuming are some sort of adjustments for the speed. And then we go out through, there are 2 micro switches down in the corner here, which you probably can't see, on a board there. And that controls the reverse and forward directions. So basically what we're going to do is I unclip the little clip that was there, and so we'll start DCing. Get this electronic stuff out of here so I can clean all this. So I'm going to go put this in a safe place. So I put it in my toolbox over here for now. These 3 leads are out to the motor. We're going to leave those the way they are. Cut these power wires here. Yeah, this cord is massive, but the wire size isn't that big. Look how thick that cord is. But that's only 14 gauge wire. This thing is massive. Anyway, that'll be replaced. So now, looking in here, we got 2 cap head screws and 2 Phillips, it looks like, that are holding all this together. Okay, that looks like that's all unscrewed. I have to take off the motor here. And luckily, if I forget where all this goes, I can refer to my video again. So basically, red to red, white to white, green to green, black to black. It's extremely possible somebody's been in here before. Okay, so that's the motor disconnected. So there are the two micro switches. Also held down here. Okay. There we go. You separated the mechanical and the electronic. That was just a couple of screws and standoffs, which we'll put over here. All these will go into a bag. Alright, gonna put this aside because we're just gonna be very gentle with this. Clean the sides off here and see if we can clean this up a little bit. This whole face comes off. Now I have a new indicator light and I also have a new fuse holder. What I'm really interested in is this shaft seal. There's no oil in here and I see a ton of oil inside of the electronic compartment. So obviously there's some sort of shaft seal in here. I'm worried about that leaking into the electronics. That board is actually pretty damn expensive. Plus this cord here on the motor doesn't look too healthy. Unfortunately, I don't see any way of replacing this cord without completely demolishing this motor. Damn it. Yeah, in other words, there's no access. There's no access to the back of it. This is all sealed. This is held in by a snap ring. I'll look online and see if there's a way to get this off. If not, you know, just leave well enough alone, clean her up. So, what I want to do here is have a peek inside the gearbox. Actually, before we even do that, what I should do is pull my hand wheels. It's held in with a retainer spring, bushing and a pin. Okay, so there's the gasket and the sight glass. And you can see the clutch right there. Let me zoom you in a little bit. So you can see right down in there is a clutch mechanism and your spring, and this right here has to be the shaft seal. Which is extremely dry. So in here it doesn't look too bad at all. Gearing wise it looks nice and clean. This gasket face is a little chunky. Not exactly sure about this seal though. Okay, so I got it separated, and I just found a interesting thing in that there was no gasket between this face and this face. There's nothing, there's no gasket material, no nothing, so maybe when I put it back together again, I'll just take a little bit of that blue silicone there and just right around it, call it a day. Obviously it was sealed before. And a couple of Phillips head screws underneath all this gookie here. So like I said, I'd really like to replace this cord. I just don't know how to get this motor apart without destroying anything. We would have to get this housing off the back here. There's a snap ring there. I wonder if I get that off. I wonder if something will come up. These here. Just had it in my hand. These here are brushes. They are rubber plugs. That's weird. Usually the brush is just right there. That's the whole thing unscrews. Which doesn't seem to. Let's see this side. The same thing there. You figured that would be for the brushes, huh? Alright, so I'll put this aside for now. I'm not really ridiculously concerned about that. In the meantime, this here can come off. Okay, I'm going to take some purple power and I'm going to clean all this up. Clean the motor up, clean the front of this up, save the gasket. And then we'll go from there.